So here we have a reliability of only 0.2, which means that the test doesn't predict itself very well, but a higher validity. And remember, validity is how well does the test predict something outside of itself. And it's kind of logically incoherent that you could predict something outside better than you could predict itself. So, so the answer is A. Now we have some items that build on one another here. What is the null hypothesis? Maybe a better thing to say is, what's the research hypothesis? That's a good way to start.
People who have score higher on a driving test.
Correct. So the research hypothesis is having a drink is good because it's going to relax and make you less nervous, so you'll do better on a driving test with a drink. So that's the research hypothesis. Then what's the null hypothesis? No, it doesn't. Yeah. At best, it'll be 75 in that case. So it means that the null hypothesis is that the true mean is either less than or is at best equal to 75. Is that clear? And then, so now we do a little study. And we have a sample size of 64, so that's our n. When we test them, they get a score of 78, with a standard deviation of 24. So these people are doing better than 75 in this, but the first thing we want to know is what's the standard error. So now you have to know the formula for the standard error, which is correct. The standard deviation from the sample divided by the square root of the sample size. So we know that the standard deviation of the sample is 24, and the sample size is 64, whose square root is 8. So we're going to divide 24 by 8, and we get the standard error. And now, according to the null hypothesis, the mean is 75. The investigator gets a score of 78. What's the z-score of 78 in that distribution? So from 75 to 78 is 3 points, and we know 3 points we just computed is the size of the standard error, or the standard deviation. So we're 1 unit above the mean. Our inferential z-score is 1. Common or rare? Common. What percentile is above, pardon me, what percentage of all the scores in sample after sample would be above 78? 16%. Correct. Good. Because we're at the 80, there's 84% below. So 16 is not there, according to this way. So what are we going to do with the null hypothesis? Do we have evidence to reject it? Is it rare? We do not reject it. Okay. So that's the logic of this. So D is the correct answer for that. So here I'm going to show you the answers, maybe not. So if we study a specific, and I've already shown it to you, but if we study a specific individual, and we normally call it a case study, I hope everyone got 22 correct. These are the particular a variable that systematically covariates with the independent variable, then we likely have a
Compound.
And then I asked you to give some, and I'm going to show you here because I accepted a whole bunch of different answers for kinds of things you might want to check for. Some of the ones that we've focused on here, intrinsic to the participants, extrinsic, self-selection, I made a big deal out of that, and things about external validity as well as internal validity, so there are a lot of ways to get that one right.
Can you put that for a second?
By going back, you mean there?
Yeah.
So I've shown you already the answers for 24 and 25. Here's one where we compute the z-score. Pretty standard type problem. Could have been a multiple choice one easily.
Can you go back to, because that was like 24 and 25, like I didn't see those. Like, and I think those were the ones that I had put in and, okay, thank you.
You're welcome.
We didn't do 26 and 27 though. You're going too fast.
I'm going too fast?
Yeah, you're killing me. Yeah, we didn't talk about 26 and 27. Okay. Okay, yeah.
Yeah, that's again the trick. When you have the variance, you normally want the standard deviation. And so the standard deviation here is 3, and now you are 6 points below the mean, where the standard deviation, standard error is 3. So you're 2 units below the mean, or -2 is your z-score. That's supposed to have an X bar, I thought it did. So this is X bar, 25, standard deviation 6. First we have the standard deviation. The standard score is 2, which means we're 2 of those above the mean. 2 times 6 is 12, added to 25 gives us 37. I'm going to flip over to this one so the answer doesn't show for a moment. So I'm asking you how many effects, including main effects and interactions, are significant. So the quick way to do this is to first ask, well, how about age? So what I will do here is I'll add 6, 9, and 12. But I might notice that the next row is also 6, 9, and 12, so they have to be equal, those 2 rows. So age is not going to differ. Then I'll add these 2 up, I get 15. I add these 2 up, I get 21. And they're already different, those 2 means. I mean, those 2 sums, so the means are going to be different. And now we know the rows are different, the columns are different from one another. So level of anxiety is going to be significant. Is that clear? We got that one as 1. We know that this one is not age. Now the interaction. So I will, let us say, subtract the bottom one from the top one here. If I do that, then the difference here is -3. If I subtract the bottom one from the top one here, I get a -3. So so far they're the same. But then I come over here and I subtract the bottom one from the top one, and I get a +6 as that difference. So are all the different scores the same? They're not, which tells me we have an interaction. So now we have one main effect and one interaction. So the answer here is 2. So the frequency distribution, what's on the vertical? Frequency. Yes.
Okay. That one was stressing me out. It felt like a trick question.
On the bottom would be-
Sometimes they're straightforward.
So the bottom would be the dependent variable?
Correct.
But if we just put frequency.
Yeah, you'd be fine.
We only wrote was frequency. It's like,
Yeah, how easy can you get? What's he doing here? Okay, so once again, there's a number of reasons why we might want to use a multi-factor design. We can look at interactions. That's a big one. Lots of variables might affect it. I like this one in particular, but there's a number of ones that you would have gotten credit for. So this is basically a naturalistic, no, I'm sorry. Yeah, it's observational study. Oh yeah, so this 32 went on to look at the second thing that I said was important for us to have when we were looking for confounding variables. So a confounding variable systematically goes along with the independent variable, but also we have to be able to tell a plausible story about why it might impact on the dependent variable. And so there's other ways you could have said this, but some story, a plausible reason I thought here, how this extraneous variable might affect the dependent variable. And that's the key one. So this is just a what is the effect of the independent variable on the dependent variable. And the next question I think is maybe a little too wordy, but and again, this goes way back. And it's an important idea really, and that is we can't study everything all at once. So if we want to answer a question of interest, what I call a big question or an important question, then we have to make it precise, or make it the homey terminology I used was, to answer a big question, you first have to make it small, but when you make it small, you haven't answered the whole big question. So it's the make work for psychology props situation. The world is complicated. You're never going to answer an important question. Say never, but rarely with a single study. But we have to make it definite in order to begin to investigate it. When we make it definite, we're probably simplifying it in some way. This is a book